Hi to all the listeners. This is China Manufacturing Decoded, the podcast that talks about topics around China manufacturing, but also around product development. In this case, product reliability, right? And there's a lot to learn from the news. And today, so I'm Renaud, I'll be your host in this podcast, and I'm joined by a very frequent co-host, my colleague Andrew Amirnovin. How are you doing, Andrew?
Hi, Renaud. Good to be here. Thank you. Doing well.
All right. So today we're going to go back on two recent pieces of news that have made big headlines, right, in July, and actually come from reliability issues, right? So the first one is the Titan submarine that imploded, and everybody talked about it for a week, right? And a lot of details came up in the press because they had been so public about how they had designed it and how they had, bent the so-called rules and so on and so forth. All right. And the second one is the very large wind turbines that have been installed, I believe, mostly in Europe, by a subsidiary of Siemens, right? Siemens Gamesa. Okay, it's with a joint venture with a Spanish company, I believe. They have installed a large number of very large, very expensive wind turbines, and then they have some issues, and then the stock of the whole Siemens group fell sharply, and so on and so forth. And this is due to also reliability issues. Okay, so we're going to go over them, and hopefully the listeners can have a few takeaways and understand a little bit better, why it's so important to think of the lifetime of the product when you design it, right? Because after that, it's kind of too late. So let's start with the Titan, the submarine that was going down from time to time to bring some passengers, some paying passengers. They're paying, it was not cheap, and they were coming down the depth of the Atlantic Ocean, going down 4,000 meters. Sorry, it's pretty deep to see the Titanic, or whatever remains of the Titanic, right? And then suddenly it imploded. So it's pretty tragic. Okay, 5 people were dead, including one who was, I think, the founder of the company that was operating the Titan, and 4 paying passengers. All right, and a lot of things came out in the press, as I mentioned. I'm going to start by reading a quote from a New York Times article, okay, where it was entitled "The Maverick Design Choices That May Have Doomed Titan." Okay, so they look at the what actually happens and try to understand, right? And one of the things they say, I'm going to quote here. There's 2 short paragraphs. "The best way of outwitting the many dangers," the expert agreed, "would have been to subject Titan to rigorous testing under the anticipated conditions and stresses. Fatigue of various materials also would have had to be considered and continually monitored. Manufacturing defects of any kind could build up over time, as the Titan endured the cycles of stress associated with repeatedly going down miles to the bottom of the Atlantic and back. Most deep-sea craft undergo costly rounds of inspection and testing by reputable marine organizations that specialize in certifying the deep diving craft as safe. But Mr. Rush, okay, one of the organizers of these tours to see the Titanic, right? But Mr. Rush obtained no certification for Titan, saying it stifled innovation. In a documentary, he said, "You are remembered for the rules you break, and I've broken some rules to make this. The carbon fiber and titanium, there's a rule you don't do that. Well, I did." Okay, so that sounds like a lot of people actually that we we work with, right? But they say, well, no, it would be
Exactly.
nice if the
You
design were
just
like
don't
this and
break.
like that.
I just have to say this: you just don't break the reliability rules.
Yeah, exactly. Exactly. Right. So when they say the carbon fiber and titanium, basically, maybe I have to explain a little bit. It's very nicely explained in that New York Times article, but and we'll put the link in the show notes, but it's behind a paywall. So you have the cylinder, the main cylinder, right around the submarine, and then you have at one end what they call a hemisphere. Okay, basically a piece of titanium to close off one end of the submarine. And the problem is that when you go down very deep in the ocean and you have a lot of pressure, they don't compress the same way. That's the problem, right? So how were they joined? They were joined by a glue joint, and that's it. So if as a lot of water pressure builds up, carbon fiber is going to compress. Titanium is not going to compress much. So every time this happens, the joint is getting sort of torn apart, right? You do that once, 5 times, 10 times, maybe, the 20th time or the 50th time, it might just break. It might fail, right? So that's typically a reliability issue, isn't it?
Exactly. I think that there were a lot of mistakes done in this project, one of which that I think that they didn't do any testing or they didn't do rigorous testing, all because the funding wasn't there and they were scared that, well, we only got one unit here, one sample, and we're going to destroy this, then it'll take us another years to come up and make another one. And so that you and I, we have run into that kind of situations when customers, they say, no, let's just test one sample. And instead of like 10 or 20 or 100, depending on what the product is. So, not enough sample, not rigorous testing. And then I think the big one was that they didn't go through certification and regulatory, let's say oceanic or shipping type of regulatory process where they would at least ask them, what kind of materials are you using? These are the strengths of the materials on this kind of a depth and so on. They just ignored everything. And just like you mentioned, he said the breaking rules, but there's just one rule you don't break in reliability because you end up with huge catastrophic failures. And in this case, it looks like they really believed that this submarine, which was pretty much made for tourism, not so much for research, under 4 kilometers of water, which you and I know that the pressure under that amount of water is enormous. And, a lot of the materials and a lot of the joints, like you mentioned, were not engineered. Yeah, I don't want to get into that. I think there was a lot of mistakes done.
Right. And that's just actually the one point that I mentioned about the titanium joined together with carbon fiber going into deep, very, very high pressure environment. It's just one thing that other people had, noticed, right? But there's so many other things. Yeah, I found something. There's someone called Anthony Dean in LinkedIn, and he said, well, there's so many things they did that scream low reliability, right? And I'm just going to go through a few of them. So first, they were using a video game controller, right? But a video game controller is supposed to be used in the living room, right? Not in a place where that's pressurized, not in a place, anyway.
Right.
And also the video game switches are not wired, right? Of course, if you have a solid wired connection, you don't need to worry too much. But when it's wireless, various things might just go wrong, right? Oh, you lose the connection somehow, and then what do you do, right? or maybe you just forget. Oh, I've this is what they call the human factor, right? Oh, I forgot to change the batteries, or oh, I forgot to bring the controller, right?
But even the
They
batteries
both
don't perform. Yeah, even the batteries don't perform the same under
Mm.
different environments. Like, in the cold environment, batteries just drain very quickly.
Yeah, yeah. Also, yeah, I mean, he listed a lot of points. I'm not going to go through all of them, but an example is every time they open the hatch, everything is subjected to the salt water environment, which is very corrosive, right? And then they have boards, solder boards that are not engineered for that, not even protected, right? There's so many things. Let me see. Yeah, the master control not on the main power bus, all kinds of things. Yeah, I mean, do you really want to control the main vehicle propulsion and guidance with this kind of video game controller, right?
Right.
What happens when you start to freak out, when you're in the wrong situation, when you need to do something in a very precise manner, et cetera, et cetera, et cetera. Okay, so basically they designed it in a cheap way to say, okay, let's see if it works. Let's do just one. So we don't need to certify it, exactly as you mentioned. We don't need to get it certified with, it's fine. We don't need to make 2 or 3 of them. And that's it. And it comes back to, let's say, an ethical level, right? Where you have a company taking some passengers, and the passengers, pay some money, and they go down there, and there's a risk for their lives, and not everything that should have been done was done, right? I mean, it's not even a certified vessel for a high pressure environment, which is pretty scary. And some of the passengers, I believe at least one German person, say, oh, I was a passenger on this, and then I complained about certain safety deficiencies, and I told them that a very bad accident could happen easily here, but did they take that into account? It seems they did not, right? So they got some warnings. They did not do much. Now, I would say it depends what you compare it with. If you compare it with, say, I don't know, entertainment, where you go on the rides and you go up and down in the air and things like that, right? Or like in Disneyland and so on. There's a lot of safety considerations, right? And it has to be certified, and it's inspected regularly, and so on and so forth. So if you compare it to that, it looks pretty bad, right? Now, I was thinking about it, if you compare it to the guys who take a group of 5-10 people to climb up the Everest, these people also pay. Actually, they pay less than going down to see the Titanic. It's what, $50,000 or $60,000, and you can go up. And then from time to time, you have some kind of accident, and the weather turns bad, like in 1996, and a few people die, including the guide, right? So if you compare it to going up the Everest, actually their fatality rate might be rather low, right? If you take into account all of the trips that they took down to the bottom of the ocean. So I don't really know what to think about it. How do you see that that wool implosion accident?
Well, I think the design was definitely flawed. They had all kinds of design-related, component-related issues that just didn't make any kind of engineering sense. One of the things that they did, for example, the hatch design. Apparently, once the team got inside the submarine, then they had to close the hatch and put in with 17, 18 huge bolts and just basically lock them inside. Even if they wanted to get out, they couldn't.
Right.
Now,
wow.
You and I both know that is not the best design when it comes to engineering, because that is one of the things that you don't do. You want to have an escape route, not lock them inside. So that's not a good idea. They had no GPS at all. There was no way for them to guide themselves. Of course, GPS doesn't work well under the water. So there are some other underwater schemes that I'm not very good at explaining those, but there are other ways that they could have done to be able to actually guide that vessel. And then there was no location beacon. I mean, that is something that just about every vessel has it, right? A location beacon. It's very cheap, easy to install. I don't know why they didn't do that. And they were basically getting their guidance from the surface. Can you imagine 4 kilometers away trying to get information from the surface? So that was not done right. And like you said, there was absolutely no operational safety put in there. There was one important thing that somebody talked about that I took a note, and that is the way this vessel was built was not to any kind of a standard, like mill standard or shipping standard. Someone made a point that, if you are making some kind of a goggle for Apple, it's going to cost you like $3,000 to buy one of those, new goggles that Apple is making, right? Something like that. But the visors, the visors that are used in F-35 fighters, those cost over $400,000 or what to the government. And the whole reason behind it is because military goes to unbelievable limits to understand the product, and they go to huge amount of reliability. I mean, the reliability that is done in mil-spec, as you and I are aware of, it is really going to the breaking point of the product. And that's exactly how they get to understand the limits of product. They come down from that and they set the operational spec. So to make sure that the product never actually reaches that limit. And in this case, there was an interesting meeting apparently between David Lockridge, who was one of the Oceangate's director of quality. And in one of those meetings, he actually objected to the fact that, for example, the non-destructive tests are not done, should be done. And nobody paid attention to what he said. There was the window that the submarine had was only rated for like 1,400 meters. That is way over than 4,000 meters. Right. So those are the kind of things that they really missed big time on this one.
Yeah. Now, I totally agree. There are standards. How do these standards and these regulations, how do they appear usually for submarines, for planes? They are written in blood, as they say, right? There have been accidents. There have been accidents, and people did a root cause analysis and say, okay, it probably came from this, or it certainly came from this. How do we prevent it in the future? How do we add a fail-safe? How do we add redundancy? How do we prevent this altogether, and so on and so forth, right? How do we make the instruments clearer to, easier to read and to interpret? How do we never get in that kind of situation again, right? But then someone comes along like a cowboy and say, okay, I'm just going to do it my way and let's see. Well, if you go down on your own and if something goes wrong, that's it. The navies of several countries are not going to try to go and locate you and spend a lot of money locating you. Who cares, right? No problem. But if you start to make it a business and bring some people and so on and so forth, I think it's easy to say after the fact, right? But there's so many ways they kind of ignored good reliability practices and the lessons learned from the past that it's kind of hard to defend them, I would say. Now, you mentioned they need an escape route. When you're down under, there's no escaping anyway, even if you can open, right? I think
you'll be under that pressure. You'll be like like a jelly. Yeah.
that's it. Yeah, you're done immediately. If you're just like 50 meters under or something, the submarines actually, they have a way to escape and to get something on their face and get up. And like sometimes some people die, some people survive. It's kind of really, really harsh, right? Do you want to try, or you want to stay at the bottom and asphyxiate and die like that, right? So people have a choice. In some cases, people could escape, but it's really at relatively shallow depths, right?
Well, you know what I think what really, really happened here was that this whole process was not done per engineering process. And if they were done per engineering guidelines, then one of the things that is a must is doing reliability testing. And if they had done this, then they would have done reliability testing on individual components. Then they wouldn't be using, for example, a controller for a video game, for example. And by doing specific tests from component level, from PCB level, all the way to product level, they would have discovered step by step, let's say build by build, or as they move towards the full product, they would have found all kinds of issues, and they would have found the root cause, fixed it, and then maybe they would have built one of them, not so much full functional for actual operation, but maybe just for prototyping purpose. And then once they get everything right, they could build one unit. And then that way, the cost could be slightly higher, but it will be done right and per engineering process. And I think that was the biggest mistake of them, not only not following engineering guidelines on design, but also doing not sufficient testing, reliability testing and component testing, and of course, regulatory and certification testing.
Yeah, fully agree. Now, I was wondering, what do you think of their assertion? The person who founded that company that put together this submersible and was going down. He said that all of the standards basically stifle innovation, and in a way that's true, because it makes it very hard for new entrants with fresh ideas, right? And that's how you have, because the US Navy has their own submarine that can go relatively deep. It's called the Alvin. Probably cost much, much more to put together, right? And test and so on. But at least it's much safer, right? So in general, what do you think of the idea that such standards basically block new entrants and prevent new ideas from coming out and being tested?
So I think what he says in a nutshell, in general, it may make sense, but I think that you have to look at it from different perspective. So the standards are put in there for two reasons. One, a company is making money from those standards. And two, there are some guidelines there, but the guidelines are a lot more often, they're not really specific to a particular product. This is the problem with the standards. A lot of times they're very general guidelines. They're kind of like giving you some hints on how you should be testing your product to make sure that in general it is actually meeting certain kind of a requirement, which are really should be known requirements that are in the industry. On the other hand, you have a product that is going all the way down to 4,000 meter. Never ever any vessel has ever done this, and that's exactly why, for example, SpaceX is sending rockets in space without, they're unmanned basically. That's the whole point. They're doing unmanned launches to make sure that the product is actually going to be safe. And in this case, they didn't do that. They didn't build the product with certain guidelines from standards, not necessarily following it to the T's, but kind of understanding what the the secret messages between the lines in these standards, and then creating maybe their own standard that actually meets certain requirement under that much pressure, under that much distance. So they could have done that, and then maybe they would have actually created a whole new standard for the industry if they would have done it the engineering way. Maybe make a smaller version of it, kind of to a scale, right? And then sending it down unmanned with a robot and cameras, and just see what's going on with the structure and so on. And then once nothing happened, maybe make it a bigger one, and maybe put a monkey in it. I mean, I'm kidding, but
right.
there has to be done some tests on man to ensure that the quality, reliability, structure is going to handle that environment.
Yeah, and also monitor, maybe, for example, going back to what I mentioned before about the titanium and the carbon fiber, actually having sensors to monitor how it's getting compressed, right? Because I just found the exact number. Every square inch is subject to a water pressure of 3 tons of force. Can you imagine that pressure is just enormous? So if you monitor and you say, okay, it's starting to retract a bit too much, okay, it's not safe, let's do something else. You don't actually need to push it to failure, right?
Right, exactly.
And you mentioned SpaceX. Actually, it's a very good example of another company that did innovate, did in some cases use consumer electronics types of components, but they had to actually test them to show that their reliability was perfectly within what the military standards were requiring. And that's how they avoided using some of the, military contractors' own components, which cost so much more. And of course, there's not that much choice, right? So they're able to pick in a much wider range of options, but they had to test the components to confirm, okay, they are reliable to the point where we can use them, right? So that was an example where they did it right. And this Titan is an example where probably it seems they did not do it very nicely. So, as I mentioned, I wanted also to cover another recent example, right? So, Siemens is a huge German company, is one of the largest German companies, right? And they are present in a number of different industries, and they tend to work on highly engineered products. And one of their subsidiaries is called Siemens Gamesa. I guess I need to pronounce it sort of the Spanish way. And it focuses on renewable energy. And they have installed probably thousands by now of wind turbines onshore, right? We're talking about onshore wind turbines. Okay, and it's a pretty big business. It's a pretty big business. Yeah, they have a fleet of more than 100 gigawatts, right? So that's huge. That's huge. That's many times more than a nuclear power plant. I mean, it's huge. Okay, and they came up with a press release or some kind of warning saying that they discovered issues in some of the components. And they mention, I'm reading in a Reuters article, we'll also put the link in the show notes. They mentioned that they discovered issues specifically in rotor blades and bearings, among others. Okay, and they say that there's abnormal vibration. Okay, and it's not just one or two of their fleet of wind turbines. I mean, that would be expected, right? There's some variations, and some of them are gonna be in trouble and need to be they need to have some components replaced. But they say that it's between 15 and 30% of their installed fleet. Again, more than 100 gigawatts, right? That's an enormous number of these huge wind turbines. Okay, so we don't know much. they haven't said much, but basically when they install these turbines, it's supposed to be active for probably 25, 30 years, right? Maybe longer. People don't really know because we don't have that much hindsight about this design of wind turbines, right? But this is in the energy sector, so everything is in decades, right? For sure, it's more than 20 years. So they say that they're trying to develop a statistical models that could translate fault rates into firm indications of how turbines are expected to perform over the next 20 years. Okay, but it's again 15 to 30%, right? So it had a big impact on even the stock price of the whole Siemens company and so on and so forth. But it's also casting a doubt on the whole. Let's be fast in doing a transition to no carbon in energy sources, right? If it's not really tested, we don't have a lot of history and learnings. There are going to be some, painful instances of learning like this one, right? So when you read about this abnormal vibration behavior of some components, what do you think, may have happened?
Well, this is just another example of a corporate greed where they actually didn't put the money on quality and reliability, and they wanted to put the money on profitability. As you know, this situation couldn't be, there must have been issues definitely with the design for sure, because anytime you have an issue of this size and this big, which is going to cost the company in the order of 2 billion or more, apparently, lost customers. They're providing this to many, many customers across the world. So this is not just a small chunk of issues. You've got, like, as you mentioned, 30% of the product returning or having issues. I'm thinking that definitely they had issues related with the design right from the get-go, because if they didn't have these issues, they would have noticed it, but they didn't do a really thorough analysis of the design, testing of the design, testing of the components that they're talking about. And then, because here's the problem I'm foreseeing what happened. The product is so huge that testing it as a whole is really not easy. So during the design and development, for something like this, what they should have done, they should have hired military-grade reliability engineers. These are engineering types that they know how to design, for example, a whole airplane reliability without having the actual sample of the product. So there is a theoretical reliability engineering that goes with this type of design. And then they actually design the product based on certain reliability goals, like you mentioned, 30-year product, certain amount of vibration need to be handled, certain amount of wind, for example, pressure and wind speed. All of these would be taken into account. And I'm talking about right down to the component and PCB level, including thermal cycling and different environmental factors, water and rain and dirt, everything, and lightning. So all of these would have been taken into account. Then the theoretical design would be, or should be, somewhat close to the realistic one.
Right.
And once they build,
it's so hard to model.
Exactly.
I'm thinking about it, because you have the wind. You have wind speed, which is not constant. So you have some areas where it's like in bursts, right? And then
but you have to look into the worst case scenarios at all times if you want a true reliable product. And then once the design was complete, then they would actually make a prototype, and then they would run the prototype through real wind tunnels and other areas, thermal cycle, to make sure that it's actually meeting or getting closer to the target goal they had in terms of reliability. And I don't think they did a thorough analysis like this.
Right. So what you are saying is basically, if we compare the two cases, right? The Titan submersible, this could have been tested by preparing a smaller prototype, sending it, pressurizing it first, and then sending it really at the bottom of the ocean and with a lot of sensors and everything, see how it goes and so on. And of course, they should have read the standards and actually thought of how to follow some of the best practices and so on, right?
Correct.
This case is much more theoretical, right? It's extremely hard to model, but some people are good at that, and there are software that can support that, right? Even the way the wind turbines are in relation to each other, because sometimes in some fields they are sort of behind each other in a certain type of array and so on. So it's really, really not simple to model, but some people actually do that for a living, right? That's what he's saying again. Aerospace.
Yes, absolutely.
military.
I mean, Boeing and a lot of the airplane companies, they are actually doing those types of modeling because, each one of those airplanes costs millions of dollars, right? So they're not going to. And once they have done the modeling and they have built maybe one or two, prototypes, then they will start doing some testing. And a lot of times, at least maybe up until like couple of years ago, where they actually did a crash landing of one of the airplanes just for testing. But most of the time, they take one wing and they'll just do all sorts of vibration testing, limit testing, how much wind testing is going to break the wing and so forth. They do a lot of things just on component level, for example. And then once they feel pretty satisfied, then they might do actual, let's say, harsh testing, in the sky with special pilots that they know how to get out of that situation when the airplane fails. But yeah, you're right. I think the modeling is not easy, but it can be done, and they should have followed that sort of mindset to be able to come up with a prototype that could actually handle that sort of pressure, either in deep sea or the turbines, the wind turbines. I think they both have a couple of things in common, as you can see, right?
Oh, yeah, definitely. Well, also, they might have done all of that, but it might be one of their suppliers that, dropped the ball, right? Because they buy from Chinese companies, Japanese companies, Swiss companies, German companies, and so on and so forth. Yeah.
You are so right about that. In fact, that actually happened to one of my previous companies where we designed a product with a Japanese, LCD, and product was working beautiful, no problems at all. And then all of a sudden, we went ahead and for cost-cutting purpose, we went with a Chinese product that was equally good product, good quality. Everything looked right, except in production, we ended up not being able to close the camera because there was a stack-up issue. Right. And then it turns out that the engineer made a design mistake, and he had a very wide tolerance, basically spec for the lens, for the display. However, for the production version, they went with a tight tolerance Japanese high quality lens. And then everybody made that a standard. And then they went and purchased the Chinese version, and the Chinese supplier said, "Hey, here's your spec. I'm meeting the spec. I don't know what you guys are talking about." And then they found out that it was all design related. Somebody dropped the ball and they made it too tight on the manufacturing, and they used the tight spec as the actual spec in production, whereas that was not the case.
Well, and where were the design reviews and the pilot runs and so on?
Correct. Right? They would have found those things. Exactly.
Yeah, right. Well, anyway, maybe no need to keep digging in as long as we don't have any more specific pieces of information. But again, this is probably a 2 billion euro write-off and maybe more. right? So
Correct.
reliability issues are maybe not everywhere, but they are behind a lot of the big problems that we hear in the news. We think about it in terms of safety for the Titan that goes down to the bottom of the ocean. We think of it as a quality issue. That's what they write in the article about the wind turbines. But when you go down to it, it's about, is it a reliable design, and are manufacturing controls in place, and also some regular ongoing reliability testing in place to ensure that continuing productions keep meeting the reliability objectives, right? So if these things were done right, we probably would not have heard of these two catastrophic pieces of news. So that was interesting. Thanks a lot, Andrew.
Yeah, I enjoyed it. Thank you very much.
Yeah, we'll do that from time to time when we hear similar kind of big problems. All right. Yeah. So thanks for the listeners. You'll hear from us next week, as always. Thanks a lot for staying with us, and till next time.
Thanks again for listening to this podcast, brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share, because it will really help others discover us too.